Okay, so this is a quick video about an application of the integral test, and it's called the P-series test. Okay, so the P-series test is an application of the integral test. And what the P-series test tells us is that the sum of 1 over n to the p converges as n goes, n equals 1 to infinity. So it converges if p is greater than 1 and it diverges otherwise. So if p is less than or equal to 1. And these are all positive values. So 0 is between p and so we're only dealing with positive values, and if it's greater than 1 then it converges, if it's less than 1 it diverges. So to see this, let's take a look at the integral from 1 to infinity of 1 over x to the p dx. So we already saw what happens when p is equal to 1, right? So we know that diverges. We have the harmonic series 1 over n, which translates to the integral of 1 over x dx, and as we know that diverges. But let's look at p otherwise. So we know that 1 over n to the p, when p is, or 1 over x to the p, when p is not equal to 1, we integrate that. We get, say from 1 to infinity, we get x to the 1 minus p over 1 minus p. So 1 minus p, that's just a number, and what we're really concerned about is this guy. So we take the limit as b goes to infinity of x to the 1 minus, or b to the 1 minus p in this case, minus, it's going to be 1 to the 1 minus p. So this guy, that's just a number in all cases. But in this particular case, what's going to happen is b to the 1 minus p is going to go towards infinity if we have p is less than 1, and it's going to go to 0 if p is greater than 1. And since p is greater than 1 in this case, that corresponds to the convergence series over here, as we showed before. Now let's look at a quick example. We've already seen the harmonic. We've seen 1 over n squared. We've seen 1 over n, which is the harmonic. So let's just look at, say, 1 over the square root of n. Doesn't necessarily look like a p-series just yet, but we can translate that to 1 over n to the 1/2. So we just look at this guy here, that's our p, and we know that it is less than 1, so it must diverge. Right. Thank you.